Inside of each brain, there is the possibility to understand how trillions of neural connections come to sense the world, record memories, create an individual, and shape who you are and who you will become. Can we ever learn how this happens?
Here in my lab at the Sanford Consortium for Regenerative Medicine, that is what we want to learn. What happens to build a brain? What happens to create a human mind? And how does this process become disordered, giving rise to conditions like autism, schizophrenia, epilepsy, and degeneration? And how can we intervene and rescue the mind from disorders, and even restore lost function?
To find these answers, these researchers and a host of collaborators are using a diverse array of methods and tools. Among them, this very novel device. What you are seeing is a truly unique robot. Unlike our domestic helper, which has basic instructions programmed from a human source, commands like turn around, go forward, and vacuum. This robot has only one command: walk. But something else makes it distinctly different. The rate at which it lurches ahead is controlled, as awkwardly as it is, by signals recorded from clusters of neural cells. The scientists are growing these clusters of neurons because neurons on their own can't tell us how the whole brain works. And at this stage, the neurons are taking an important step in development. They are starting to signal in unison. Is this how neurons start to organize communication in the young brain? Eventually, the researchers hope to send signals from the robot back to the neurons to investigate how signaling develops and helps the brain to organize and grow. The young neurons providing the signals are special not only because they have started signaling in unison, they are special because the clusters they are in are actually self-organized groups called brain organoids, because they have many of the characteristics of a developing brain. These brain organoids are the focus of these researchers' many investigations.
One focus is to grow brain organoids from pluripotent stem cells, from individuals who have neurological disorders. These let us see what differences there are between normal and abnormal development, and even ways to treat the disorder. Brain organoids also let us see very early brain development. These earliest stages of brain development are when errors that cause disorders occur. Disorders that will affect the brain for life. And this is why we're working with brain organoids. To reveal how a brain is built, so we can see how it works, how neurodevelopment can go wrong, and how we can prevent that or fix it when it does.
The researchers are taking many approaches, from the details of vision to how neurons connect and form networks, to engineering ways to help organoids become more complex, to the differences between typical brains and brains with cognitive disorders, even to growing brain organoids in space to understand autism and Alzheimer's disease.
We will be visiting with our collaborators to discover the many ways brain organoids will help us achieve these goals. So come with me as we explore building the brain.